start by posting the agenda as it stands, and feel free to throw some stuff in here as well, everyone, as needed. So I have a couple updates about the specs coming up. I know Quinn's been doing some more work on the Rust implementation. So if you have stuff to talk about, Quinn, throw yourself on the schedule. And anyone else, I'll go back and refresh that from time to time here. But maybe I should just, unless anybody has anything else they want to say to get started, I can dive in and give people sort of like a very high level overview. And there's going to be more videos and materials coming like over the next couple days. I want to record some Loom videos and stuff, like doing deep dives into the specs. But before I dive in, does anybody have anything, a word they'd like to get in edgewise before I take over the next 20 minutes? I'll take that as a no. Great. Yes. Actually, Quinn, it might just be easier to say that comment out loud for the video before
Sure.
we go into all the specs. So yeah, if you and or Philip would like to talk about that a little bit.
Yeah, sure. So I was basically just saying that I don't have too many big updates because the last 2 weeks have mostly been travel for me. But the most exciting news on the Rust UCAN side of things is that Philip is actually using Rust UCAN internally on the Fission server now. So we've been doing a little bit of work there to polish up some of those APIs, make them a bit easier to use and so on.
Yeah. So we decided to re-implement our server and sort of like modernize updates and stuff in Rust. So this is bringing everything up to date to the latest and the latest you can, basically. Awesome. So let me tell you all about the updates to the specs. So I was typing up a storm. The bots in the Discord probably going wild with updates a little bit in there. The really short version is that for a long time we only had delegations, and had come at it with more of a trying to jam both invocation type logic and delegation logic into a single token. And when we started breaking that out into invocation and delegation as separate formats, like completely separate things, that sort of liberated us to break out a lot of use cases. So a lot of things that were that nobody was really happy with for a lot of the history of the UCAN have gotten cleaned up significantly. And as part of this push, which was originally going to be like, let's just clean up a little bit and move forward. We've so the trade-off is I may get pilloried for saying, we'll probably ship 0.10 as the 1.0. There's a few more changes. The basics are still there, the semantics are still there, but we've made it, I think, significantly easier to implement, to maintain, to understand when you read a token, and supporting all of the existing use cases, and I think maybe even a few more. The feedback so far from people that have done deep dives into the specs or that I've walked through, mainly people who've done implementations before, like Philip, like Ugo, Rackley, who I don't think is on this call right now, has been overwhelmingly positive, right? We can check way more things syntactically. We rely way less on we still need plugins, okay? But we rely way less on them. So things are much, much clearer. There's way less surface area for a confused deputy. And we still get to maintain all of the nice partition tolerance stuff that we've wanted. I've also been, so I was mentioning to Alan off the top of the call, I've been here doing some local first, I'm traveling right now. I'm in Portugal doing some local first stuff and talking to them, people here about that use case. And UCAN continues to really tick those boxes really, really nicely. And even a lot of edge cases in that community that they're worried about. And like, when can I do eviction of the CRDT store, things like that. There's actually good answers for in the structure of the UCAN now. Chris.
Just curious, are we talking about 0.10 or a post 0.10 spec?
This is a post 0.10 spec.
That was my question. Just curious.
Yeah. Okay. Great. I'd hope to have it actually like done, merged, good to go for today. I unfortunately got a little sidetracked, ending up in Portugal. So sorry. It's basically good. There are, as far as I can tell, no substantive changes to this. I've now run it past a bunch of people. It will go into ready for review very shortly, basically. I've had a few, I'm currently at arguing about field names, right? The overall semantics, people seem to basically agree, which is, oh, there's a baby on the call. The overall semantics, people basically agree at this point. And again, people who've done implementations in the past seem pretty happy. So there's still time for review. There's plenty of time still for people to argue about stuff, about how the things will exactly land. But I'm in a pretty comfortable place. There's just some inconsistent naming right now that I need to just go back and clean up. It's like in this version of the spec, it's called do, and in that, in this example, I have the field name is do, and that one it's CMD, and like I need to do a pass to make sure everything's consistent before I open it up to the whole community. Alan.
Yeah, just one question. Did you get a more advanced use case than just a single call? Read this object, where you're passing a parameter or you're getting a return value.
So for we still need you mean on invocation?
Yeah, an invocation.
Yes, we definitely have we have a very concrete use case that makes use of both promises and passing delegations in the invocation.
Okay.
So it's essentially passing we used to try to do rights amplification in the same token.
Right.
And we basically said, no more of that, no more multiple paths. We're doing a late binding on the delegations. And it looks much more like a classic OCAP invocation now.
Right.
Yeah, much closer.
I'll try to get time to look through the spec. I was waiting until you gotten to that.
Yes. Yeah, thank you. Yeah, there's it's sometimes hard to balance, like how early do I get feedback when it's still in progress. Let me clean up make all the examples consistent, and like all the text consistent. And then, I'm going to flip the switch on all of them, and then I'll ping a bunch of people in the Discord to take a look at it. Yeah. Let me give you share my screen, and I'll give you a high level look at what's happening. Sorry, I switched over to the agenda. So now I have to click through to get back to this. Okay. So great. Everyone see my screen?
Yep.
Great. I see nods. So big change number one, I broke the spec out into subspecs. There was a lot of detail, and we were trying to shove too many ideas into one place. And strictly speaking, you didn't have to implement, when we talk about implementation burden, right? Not every use case needed the entire thing, right? Like if you didn't want to support revocations, let's just break that into its own spec. This has turned out to be a massive, massive positive, because every item now has a motivation section, a related work section, or prior art section, space for diagrams, discussion. There's a lot more space for each concept. So I wish we had done this earlier. There's 4 core specs: delegation, invocation, promises, and revocation.
A quick question. Can you post that link? I seem to have the wrong link to the spec here. I'm not seeing what's on the screen.
Okay.
You're on the high level branch?
I don't know. It just says spec. UCAN working group spec.
So this is in a pull request still. So this isn't merged yet.
All right, that's why I'm okay.
So I posted the in the chat.
Okay.
Yeah, so a lot of the pros is still the same, so I won't go over that too much. Here's how they're all related. So again, the actual semantics are the same, but there's just a lot more describing what's happening now. Delegation and invocation are required. You don't have to support promises if your use case doesn't have them. You don't have to support revocation, though it's like recommended. What I found with promises in particular is people look at it, go, that's unfamiliar. Why would I want that? Is it okay if I just don't implement it? I'm like, sure. And then 3 weeks later, they're like, oh, that's why you would want it. I'm like, yes. So they've enabled quite a lot for things that we're doing at Fission. And I think it takes a little bit of time to have that light bulb moment of like, oh, that would solve this and this and that. And then I can have almost like an RPC thing. It actually ends up being really nice, but it's broken out into its own thing. It describes its own motivation, et cetera now.
By the
So
way,
here's
I recommend that for people who like debugging, because as soon as you introduce promises, you'll have many happy hours debugging.
yes, yeah. So the relationship between them, obviously an invocation is proven by one or more delegations. A promise invocates awaits invocations and then kicks them off when they're ready. And revocation is now a kind of invocation. So this is something we had played around with a while ago. Seems like a good idea, and it also lets you delegate in this conception rather than making it its own whole format. It just folds it into the way everything else works. And now you can delegate to somebody not the ability to do something, but the ability to revoke that other credential. So you can essentially have like a kill switch that somebody has, but like not the ability to actually do the thing themselves, which we've ended up. So that was suggested by Aracely a few weeks ago. And it actually, I was like, oh, why would you need that? And then I started to think about like, oh, actually, that's pretty nice for the people that want it. Why not? Let's just make it a delegation type, right? A lot more diagrams and description in here. We have a really explicit, this example is for how to do this with a CRDT. So when you don't have a single place where things live and you have concurrent edits and all this stuff, how do you actually use this for the push-based invocations? Like I want to push a write to somebody else rather than pull in from somebody's data store. What does that look like? So this is sort of like the normal WinFS or presumably subconscious flow. So there's some examples with that. We'll actually produce full like test suite examples as well that people can test against to be like, I want to implement this for these new fancy data structures. How would I do it? Oh, like this. Okay, great. And I've had a bunch of discussions here with the local first people about this, and I'm pretty convinced that this works for those cases. Moving a bunch of things that used to be in ASCII into Mermaid, no big deal. Most of this is the same. The big change, really, a little bit more of these. The biggest change is, or I guess there's two. So if I go into delegation, to load on my hotel Wi-Fi. Okay, so we merged in a bunch of changes that people have proposed, like these should be expiration and timestamps should be 53 bits instead of 64 because JS basically you don't want to overflow the numbers. Sure, great. Really, the big one is this no longer has a proof chain in the delegation. It does in the invocation. So we've just moved that. We've turned it from an early binding to a late binding. And this has a bunch of non-obvious, really nice consequences for both for the invoker. So if there's a revocation and they can get delegated some other path, they can just or there's a healed path in the middle of that chain, they can reconstruct and not have to get the entire chain redelegated to them, as long as they can get a hold of this. So that's one nice thing, and it makes checking much easier. We no longer have to say, well, at delegation time, you have to provide us every possible path that might be used. you get a straight line, and we'll look at that momentarily in invocation. But it's like this exact thing right now. It makes checking time bounds easier because you don't have to say it always gets narrower. It's like, is it valid right now? Yes or no, right? So it makes a bunch of these things simpler by doing this late binding, which is really nice. Consequence of that is we need to know what the root credential is, and we don't have the entire path at delegation time. So we've added this field subject, which is the root issuer. We just pass that around in the delegation chain. Most of the time, we think people will just use that to identify their resource. So a pattern that we've changed is instead of registering the user's did in a database somewhere, which is kind of this like middle ground between the two, we're still trying to do user agency and what have you. We give the resource, this is much more capabilities oriented, right? We give the resource its own key pair. Benefit one, this acts as a truly globally universal identifier because nobody else can fake it. There's a secret involved. There's a private key, right? It delegates to one or more parents, just like you do in normal capability systems. So when you create something and you tell it, hey, I want you to do the initial delegation back to me, back to Aleph and Bob, right? If you want to, sure, why not? Or not, if it's going to manage its own state, so for most things, we think that did will be actually sufficient to identify resources in the network. If you want to say this resource manages, I don't know, this database by name, or you can only call this particular URL, then in the body, you can say URI : this thing. So that's what we used to use the with field for. I would say like, we're going to figure out who the root issuer is by looking at the delegation chain and with this URI. But sometimes that was awkward. Like it wasn't really URI. You were talking about the root resource or the root issuer. This sort of flips that around. When we were looking at the design, there were different trade-offs. The nice thing about this is it's really explicit. Who the root issuer is, what their interface is, what their semantics are, what the shape of the arguments are for the invocation. It makes things very, very, very clean and takes a lot of the checking out of the level of semantics and makes them purely syntactic. And we'll look at that one little bit more. And again, I'm going over this like just the important stuff at a high level. There will be deep dives and documentation very soon. Can has not changed. It's still a string. It's an arbitrary string. By default, we put a slash in it for namespacing. You don't have to, or you can use a different thing. It just has to be a string that identifies the shape of the what will get eventually invoked. Arguments, still a map. These are things that you can think of them as partial application of the function. So if you need to have URI and tags and author as the three fields, you can just set, tags, let's say, and that tag verbatim has to be in the arguments of the invocation, right? Simple. You're just partially applying. This field, if Ugo just 2 hours ago suggested con for conditions, which I actually think is better, is what we traditionally use as caveats. And is sort of like your open extensible validation checks. But now they're driven syntactically. And Alan, I'll get to you just in one moment. So it used to be this sort of like, you have to understand how they work and what they mean, which is fine. And I think there will still be some of that. Now, so here's an example of a set of them. They're constraints. So anytime that it's not fixed to this field, this thing, if you want to say, well, the field's 2 in an email, that's an array. It has to at least include bob at example.com. So I'm not going to give you the exact array, which would be in arguments. Here's one constraint, and you can just append more constraints to the end, and then we just check it syntactically at the end. And you only have to do semantic verification now when you actually go to invoke. So it makes implementation much simpler. We can ship a standard library of these that handle the 95th percentile use case and give people the ability to plug in for more things if they need them. So, elements on the to field have to match this regex, for example, right? Like, we can just do pure syntactic stuff, which makes the delegation checking very, very simple. And the only one who has to understand anything semantic is the subject who you're calling. So, Alan.
Yeah, I just wanted to double check in the ZCAP LD spec, they didn't make it clear that the caveats could only reduce the scope, could not increase it, and that's got to be called out explicitly.
Yes, and it is in several places. So you can only at the level of delegation, you can only fix arguments in place. So this is sort of this like partial application idea. So you're reducing the degrees of freedom somebody has for the next delegation or for an invocation, or you're appending some conditions, and all of those conditions must exist in the next delegation. So you can only append to this list.
Right. But the key is that they had one example where the caveat actually expanded the permissions. And so you just want to make that explicit that they will only narrow the scope.
Yes, yeah, they'll only narrow the scope, and I think we can give some validation logic like pseudocode, which is a suggestion from Quinn a couple of weeks back, of how to do this checking. And so all of these caveats talk specifically about, like, it used to be a description of some semantics, and then you'd plug in your custom semantic checker. Now it's saying, at the syntactic level, we're talking about the arguments. I know the shape of the arguments from the can field. That's a type discriminant, basically. And then the arguments get constrained by these caveats. And so there's no way for me to add more power to it because I'm only reducing. Perfect. Purely syntactically driven. Yeah.
Perfect.
And we do say in a few places has to always narrow.
Yeah, in the ZCAP LD, their example was non-normative. So it was just an explanation error. But this is a point where people new to capabilities get confused. And so be as explicit as you can about that point. Yes.
Yeah. And it's something that we used to have, or we tried to jam rights amplification into delegations because we only had delegations for the first while. And now that we have invocations, we ripped that out of delegations in this version. So
that's the right answer, I believe.
Yeah, it just reduces the surface area for some of these edge cases. So, and in a way that I think is easier to implement and easier to understand when you read the thing. It's like, oh, okay, these are constraints on the syntax, not on the semantics, right? So that's a little bit of validation logic, diagrams of how everything has to line up, examples for it, actually exactly this. These are equal. I can add fields to my caveats. I can't remove them, right? Or I can add more caveats. I can't remove caveats. Great. Alan, you have your hand up again.
Yeah, you got rid of the thing about at invocation time searching for multiple paths to find one, because now it's just a linear chain of delegate. Perfect, because that was a vulnerability waiting to happen.
Yeah. Charles?
Just to be clear, so now each delegation can only give permission to do a single type of action.
Yes. So we looked at this really long and hard for a long time. We know that you need to be able to sign so at signature time, when somebody is actually producing the UCAN, we don't want to bother users with, they're doing 100 resources that they're delegating 100 passkey prompts. Like, that sucks. We're not going to do that. So the two approaches are, what we were doing before was a batch envelope. So you have at the time, JWT, and inside there was a caps field that had a bunch of resources in it. And then you signed over this whole thing. And now when you do your delegation paths, like, I actually still think that it was clear in the checking logic, but it leaked information. It was a little bit like there was more to implement, right, to get that to work. It was fine, but like, the other method is to do batch signatures. So to roll up a bunch of things into a Merkle root and then sign that Merkle root. And then you provide the signature of the root CID or the root hash and a Merkle path, Merkle proof to the specific token that you're talking about. There's at least one or two specs in the W3C and IETF trying to do this. They haven't finished them yet. So one is about TLS and one's a general mechanism, the two that I found. And they totally work. It makes sense. We're just gonna have to define our own in the meantime, but like it's a Merkle tree. We understand how these things work, right? And so as soon as it's like, okay, we're going to, the other switch worth noting, the default token type is IPLD now, and we can represent arbitrary IPLD as a JWT, as a signature type. So in the same way that you've been thinking about passkeys as a signature type, JWT is also a signature type. It's like, this is an RSA, but first it got turned into a JWT and then we signed it.
Cool.
Alan.
Yeah, as long as that's what that's cool.
Yeah, I just want to make sure that on the invocation, you designate a single resource, not the Merkle tree.
Yeah, exactly. So in invocation, which looks like, let me get you a full example. Yeah, so this is a complete, here's the signature envelope, like everything, the whole thing. Issuer audience, run this command with this at this user. So this has to match the subject field for the chain. It's the root issuer, right? With these arguments. So it's a single thing.
Right.
And then you can chain a bunch of these together with promises, which is broken out into its own spec now, right?
Okay, so if I have one of these Merkle tree UCANs, delegations of one of those, when I invoke, I have to delegate to myself to the single resource I'm acting on.
So all you need to do, each the signature, let me show you, they all have the ability to do this Merkle proof thing. So they have sig field. Yeah, okay. So they have two fields. One is a signature, which is just the bytes of the signature, and any Merkle proof after it.
Mm-hmm.
And the hash of the single thing that you're talking about right now. So the signature happened over this entire set of things. And then I'm going to identify, I'm invoking this, and here's a Merkle proof for that one.
Okay, rather than create a new delegation, which would have the same effect. Okay.
Yeah.
I'll have to think through that one.
Yeah. Yeah. So, but yeah, you're only like, if you wanted to invoke a whole bunch of things, like you want to do 100 invocations at once with one signature to scale signing time, right? Or to reduce the number of times you have to ask a user, with the pop-up, do you want to sign this? You can ask them, do you want to do all of these? Yes. Single signature. And then each invocation has the signature and its individual Merkle proof, like the path to it in the Merkle tree. And so those travel separately. It's just this at signing time, we signed the root.
Okay, yeah.
So you do get individual tokens.
Yeah, that's fine. The direct way is an individual token for each one. That can be excessive. So this is probably okay. I'll take a look and double check.
Okay, awesome. Yeah. Pretty much the same as the last, not pretty much the same. It's the same as the last version. People complained that the naming was confusing in a few fields. And we had a lot of look, I have a programming English theory background. There was a lot of PLT terminology in there. So we're just trying to simplify the naming of these things a bunch. And then, yeah, proofs are now just a linear set of delegations. So it's an array. If that array is broken for some reason, you don't have to check another branch. There are no other branches. You reject it and you say, give me a valid one. Because presumably now, because you're making these invocations, you probably have a live connection, right? So you just reject it, ask for a new one if they can provide one to you. So it makes things just narrows down the number of cases you have to handle in code. And that's the late binding that I was mentioning before. And yeah, those are like the main differences. Revocation is now a kind of invocation. So it's UCAN/revoke, and the argument is the CID that you're revoking, like the hash of the delegation that you're revoking, and optionally a proof that you're actually in that delegation chain. So you can say, hey, between me and them, here's the path, right? Or here's a path. And a little bit in the spec, there's the exact validation logic for when you receive a delegation that may be revoked, how to check if it is. So again, I'll record some videos with all of that. I just don't want to take up all the time live here on the call. And then, yeah, we have receipts as well. So a standard receipt form, which was also in the previous version. Again, very little has changed here. Some field names have moved. And in practice, what we're finding with these, especially if you have, I think it's in this spec. Yeah. So especially if you have a chain of them, where you have an invocation produces a receipt, that receipt asks for the next thing to happen. And then you take that and you're like, yep, cool, I'll sign over that. And here's the next one. You can chain them back. So you essentially get a distributed stack trace, which is actually kind of nice. Sort of unexpected nice thing that popped out of this.
Actually,
the other two spec.
Actually, that chain is necessary for your audit trail.
Yes, exactly. Yep. Yep. But each of them will have their own delegation chain and all that. So like they're technically self-sufficient, but if you need to go back and audit the provenance, that's why it's there, exactly. And yeah, there's also a little bit of, in the promise spec, there's a particular, if you're on the error branch, something went wrong, we couldn't resolve the promise, you timed out, whatever, we have a specific format to go into the receipts to be like, yep, this broke, here's why, it was from over there. So it ends up being really nice for debugging, basically. Promises are identical to before, they just have their own spec now because we wanted to break them out. And yeah, revocation is formatted as a delegatable thing, so it gets invoked, but otherwise is like the semantics are the same as before. Yeah, so we're at 2/3 of the session. Let me pause there. And again, there'll be more detail, and I'll flip these to ready for review like shortly. I just need to make sure that the field names and all the examples and stuff are actually not confusing, right? Thoughts, concerns, questions? And one final thing is Fission is leaning much heavier. I think I mentioned this last month. Fission is leaning much heavier into this stuff. We're narrowing our focus from doing a bunch of things to really UCAN focused things going forward here. So there will be a lot more libraries and code and helpers and things, revocation store, we're going to ship it. We'll ship it as a separate crate, and then other people can use it. We're going to ship a TypeScript version separately from the Rust version, right? So like there's a couple of these things that become more efficient. Fission's willing to do the heavy lifting. My mic isn't working?
I can hear you.
Yeah, Quinn, you sound very garbled to me. That'd be a sound subsystem thing. Everybody else can hear me?
Yep.
Yeah, okay, cool. Yeah, so we're going to ship a bunch of stuff that makes it easier for people to like, it's a community effort, right? Subconscious did a lot of work earlier this year. shipping libraries that benefited everybody. We're using big chunks of that code. Fission's going to take some of that maintenance burden right now because we need a bunch of this stuff, and we're now focused down more on UCAN related things. So let's ship a bunch of stuff, and then everybody can use it, basically. So with that preamble out of the way, 20 minutes left. What do people want to talk about? Questions, thoughts, concerns, other topics?
Do you still have wildcard UCANs?
We do. So those work actually in a lot of ways very similar to how an OCAP system would, where you're saying you're allowed to issue arbitrary commands at me. You just have the reference, right?
No, I meant the resource wildcard.
No,
Those are
gone.
Okay,
Gone.
Well,
Yeah.
Then how do you handle the case? I want to delegate to you everything in this collection, even things that aren't there yet.
Yes. So that is okay. So instead of being a wildcard resource, we've taken those same semantics, and they're now pushed into the can field. So can star. So we're saying on this subject, you can /redelegate anything that comes into them. So it's more of a power box style.
Okay.
Ugo and I were talking not 2 hours ago about, you know what, actually in this new world, we may actually be able to collapse that down to the same as get rid of the one case. So there's you can issue any arbitrary commands to me. It's almost like the maximum permission in the delegation. And this power box emulation thing, which is /redelegate. I haven't had enough time to make sure that there's no weird edge cases, but we actually, again, in this new version, we might be able to do literal power boxes without needing the separate without the separate can type. I'm going to do some diagrams and some thinking around it. I mentioned it just before this call in the internal Fission Discord, and there was at least one person that was clapping, basically. So I think it's confusing right now, the distinction between the two. I would really like to get rid of one case, and then it just becomes really simple. You don't need to do any emulation. We understand how these things line up, and it gets rid of one case, basically. And we can do power boxes in the classical style, I guess, if you want to put it that way. But I realize that's not a full explanation. I will produce diagrams. We only talked about this 2 hours ago. So. Other thoughts, questions, concerns? Otherwise, I'm going to pick on Charles and ask how your work's going and how you think this will merge. Quinn can't reconnect. Sorry, Quinn. You'll have to watch the video after.
So we have a long-standing pull request for 0.10, but at the same time, one of my colleagues has been refactoring the libraries on top of which that is implemented. All of our did method implementations and stuff. So it's basically waiting on that. I think all of the changes described would fit pretty well in what I've been doing. In particular, moving delegations to be IPLD with varsigs sort of removes the need to go out of the way and use cacals. Because in principle, we could just change the recap format to match this new version of delegations, and then use a varsig to do what the varsig's doing now in cacals, which is super, super nice. I think the biggest thing for us right now is that using passkeys, my initial thought was that for everything you want to let someone do, they'd have to make another delegation using their passkey, which is annoying for them. But I think, like you described with the Merkle tree, that would be totally fine. The final thing, I guess, that I can immediately think of would be, I don't fully understand yet how the subject key pair is used, if that actually is used to sign something or just used to represent a root for some resources.
Yeah.
We have individual nodes that replicate all the resources between them. So no key pair represents the logical resource. It's like any particular node has its own key pair. But we do mangle the owner of the container's DID to turn it into a URI, which is not a DID. Which I guess we could just use as the root. But if the key there is required to sign some things, that could be. I mean, I'd have to look at it more, I guess. But I can't see any places where that is used to sign things, so maybe it's fine. Those are just my initial thoughts. But otherwise, everything being IPLD and using varsigs and stuff closes kind of a logical loop, which is really nice. Yeah, and especially revocations being a type of communication, that is really nice.
Yeah, it's too bad Rackley isn't able to make it. It was his idea. I think it's fantastic. Okay, so a couple of things in there. So the subject has to be the root issuer, so they have to have signed something at some point. This case you have where there's like a almost like a proxy in front, like it sounds like it's a container with things inside of it, right? There's proxy in front, and you don't want it to sign everything that's coming through it. Daghouse had essentially that case as well with a work stealing queue. And I'm not gonna lie, it took me a couple minutes to think through like how do you actually do that, like in a way where you can prove all of the like that I was permitted and that was like going to the right place. And I actually like I was trying to show Ugo earlier, there's a diagram in one of the specs with exactly that. So it's doable. There's a particular pattern I would follow. I've started just writing Grand Vetter diagrams for everything and just like implementing them. Essentially, we have this case where we want to have this automatic redelegation, right, to happen because for example, we don't want a live root key on our server for somebody to break in and steal, right? We want to keep something totally offline. And so we do these pre-delegations, but it's still like that's the root of authority, and that's the identifier for the service. And so you make requests to it, and you use that Powerbox automatic redelegation proof to be like, yep, I'm allowed to. That was delegated to me because I have this path of authority. And if you want to grab something out of a work queue. So that's our case. The Daghouse case, where it's essentially you have a gateway that's just dumping stuff into a work queue, and then you have workers pulling it out, and you want to spin those up and down, sort of like ad hoc. You have a delegation to the first worker that says you're allowed to pull stuff out of my queue, and then you take the two of them, and you can start pulling stuff out of the queue and prove, yep, this was for them. They dumped it into the queue, and they're allowed to grab the work out and actually do it. So it actually connects up really nicely, but it requires thinking about it in a particular way, and that's if you want it to be provable. So I don't think Daghouse, I'm unclear if Daghouse needs their case to be like fully provable because it ends up just getting dumped into their system, right? But it's nice in this, what's the term, like mutually mistrusting scenario where like maybe these workers are distributed and I want anybody to participate, right? Well, I probably want to say, yeah, you're actually allowed to pop stuff off the queue because you're not going to pop it off and drop it, right? So
yeah, that's the approach we've been taking right now. But actually, what you said about I missed that the subject is has to be the initial owner of the resource, but that's actually perfect because that's how that's sort of what we've been doing right now by mangling this URI, but doing it this way means we don't even have to have this extra little weird URI type, which is super nice as well. Cool.
Something I should probably mention about varsig. So varsig itself, I think, is still generally useful because we need to be able to describe and have that sort of header metadata move around with data structures in the general case. Like there's somebody signed something and they didn't say what kind of signature type it is. So I want to put that on the outside of the signature. Yeah, cats and babies today. Right? It's a good call. I like it. when we're designing our own types, certificate types, this is something Quinn brought up. Too bad she's not here to explain more. You want to sign over the signature algorithm as well, which is why JWT has the algorithm field. Varsig will at minimum have then duplicate information. Because you'll say on the outside, here's header information, and then on the inside, this is the algorithm I used. So I'm actually unclear if UCAN needs a Varsig, or if maybe we use Varsig, but just like the, hey, you need to do your own checking version, because it forces you inside to check what the method is. The did alone isn't enough information, because even if it's a ECDSA key, how was it hashed? What was the exact method used? Like all of these things. So we actually do need to push some of this information, I think, into the token. So there's one spec remaining in this whole flow that I think will be quite short, which is description of this Merkle tree structure. And I think we just generalize it in that envelope. It includes, you need to tell us, and then we'll sign over, this is the exact method that we used.
Yeah, we could in principle, like that fast version could just be use the same byte descriptors we use in Varsig and just put them in the payload somewhere and say must match.
Yeah,
basically.
Yeah, actually, that's actually kind of nice. That would be very fast, which is good. Yeah. Somebody inside of PL was poking around, saw Varsig, had some unkind things to say about it, and like shouldn't
Dave
be like this.
Dave Huseby libp2p for the record.
Yes.
But it was literally because he'd never heard of Varsig, and he asked me. He's like, "Oh, you're doing the multi-formats thing. Is there a multi-signature?" And I'm like, "There's Varsig." And then I don't know. I don't think he read it and thought about it and then applied it to his needs. I think he just immediately came with preconceived notions. But go on.
So like without getting to the whole thing, I was flagged to go look at the discussion in Slack, and going through the list, I'm like, yeah, you definitely haven't read the things like the default implementations in OCaml. I'm like, no, we used OCaml to highlight the IPLD schema, like as 3 backticks OCaml, because it highlighted it correctly. So I don't think that there's it should be like this instead. I'm like, we considered that design, it was rejected by the community for these reasons, so, but it's still good feedback, right? I'll take the feedback, but it's still worth noting that somebody looked at it and went, I don't know, right? As a first gut reaction. So, I don't think that there's anything in there that's dangerous, right? You should sign over the algorithm, and maybe we just make sure that matches. I actually think that's perfectly reasonable way of doing this. But yeah, it's like also a question of how much is Varsig going to change? I don't know. See, I think it's meeting people's needs, but we should think about it before we finalize that. One.
This was my only agenda item today, so I'm glad you brought it up anyways. It was already on the agenda. My question, I read that exchange, and what I couldn't tell from the way y'all were talking was if it was a matter of aesthetics, like, oh, I want to be able to parse the prefixes in a different order for whatever reason, or if it was actually impossible in his use case to use them in that order. Like,
I believe it was a matter
for like
of
length
aesthetics.
reasons. Okay,
as
long as it's aesthetics, like he can take it or leave it. But my concern always with any multi-format design is like you need these corner cases where you don't know how long the elements are from the prefixes, and then you can only use it with a car file or with some other kind of like additional context to tell you when the segments end. So like if mostly like tag me anywhere someone comes into the Varsig Slack or GitHub or whatever, complaining that their use case is impossible with Varsig, because that's like a actual actual issue to mediate. But yeah, I am curious if because libp2p would be a pretty big well, this like other form of IPNS he's working on would be a pretty big consumer of varsig, and like whatever, it's not like varsig has to work for them. It's more like if varsig works for them, then there's like a lot of people with a lot of money and a lot of engineering resources that would support this at IETF or whatever. So like I'm kind of like I'm curious how workable his aesthetic qualms were. I'm gonna try to work on him. Like this isn't top priority for him, but over the next few weeks, I'm gonna ask him to come back and think about it a little more slowly.
Yeah.
You could probably tell there's like a personality type thing here, but it's like slow down, read the spec.
There's definitely a personality type in there as well. I love that this is recorded. I would love to hear more about his concerns, maybe even on a live call. So for the group, basically this was 2 weeks ago or something, so I may misrepresent the point because I'm doing this from memory, but basically was like, well, most signature formats have the name of the signature algorithm, a hash, and then they need to know more about the length, and then you can shove more stuff in. I'm like, that was the previous version. The feedback was a lot of signature types have a bunch of extra fields. So let's just, what if a particular, I think EDDSA even specifies the hash type. Why do you need to break it out? You can infer that from the fact that it's EDDSA, right? So there are a couple of these arguments like, that's a fair point. So let's just have a switch statement on the first, whatever it is, byte, I think, or I guess it's a varint. And then that will tell you how many fields there are. Okay, fine, right? So there are reasons it is less general. You can't write a single implementation that handles the first, however many fields for all of them, which I think is the aesthetic impulse, same one that I had. So I think it's a very reasonable thing to have. But yeah, we're really in the minutia of this other spec at this point. But before we do anything, decide to do something or to not do something, if they have a real use case for it, let's chat about it. Like I'm not, I have no ego about this stuff. I'm not precious with these things.
And
let's change it if it needs to change.
And that's also like a multi-formats wide issue. This thing about like, could a general purpose library or crate exist for this multi-X? And the multi-formats like core implementers have been, they actually told me like this week, they're like, actually, we need to remove the implementation section because people expect to be able to rely on a general purpose library. And over time, like one by one, all the other multi specs sort of stop having a general purpose shape. That as people bring more and more use cases, you eventually have to like assume a number of prefixes or assume this or assume that or not support these options so that you can assume other things. So it's like that's sort of a general problem of multi-formats, that people want the multi-based library or the varsig library,
right.
and I think that's maybe something we need to make clearer before it goes to IETF.
Yeah, I think varsig. So all that we hooked into multi-formats was like, here's a prefix that says it's a varsig. Look over there at this other spec. So I don't think you have to standardize varsig in the IETF yet. It's way too
no,
right?
way too early. We need years more. We'll take version 4 to IETF. Don't worry.
But I would love to learn more about what these edge cases are and whatnot. If you have time, if you could even just like bullet point sort of like the high level concerns as you remember them and send them to me on one of our many communication channels, that would be really helpful, actually, just for my own understanding.
Yeah, I'm gonna follow up with him first, so it might be a few weeks because like I want to see, because he just sort of has like a v0.9 that he's showing internally, and like his pain points might even be resolved with other libp2p engineers. So it might be like once things have trickled through and he has a v1, then I'll talk to him and get more structured feedback.
Right. Yeah. Awesome. Thanks. Anything else people want to chat about? Alan.
Quick question. There's the idea of using the Merkle trees instead of the star, the wildcards. is very intriguing. I don't think I've seen it before. I was wondering if you is ready for me to send out to the Cap Talk mailing list and get feedback from those folks,
Uh,
or just let me know when it is.
Yeah, I'll flip it to all these specs ready for review, and there'll be a specific one for signature formats because it crosses over all of the different specs. So you can sign everything, right? I'll tag you on it.
Okay.
Maybe a point of clarification there. It doesn't get rid of the star. It lets you sign over it lets you scale your signatures over arbitrary data, right? So there's just like a payload and a signature. And maybe some of the things in that payload are not even UCANs. There's like something else, but we just want to give a Merkle path and like not have to sign 100 things for 100 different resources.
Yeah, no,
They can be delegations to different people, yeah.
Yeah, but just using it for as delegation UCANs is an interesting idea. And I thought if they, these people would be interested in that and might find some corner cases that you and I haven't thought of.
Yeah, no, I'd love that. I think that'd be really great. Yeah.
Okay. So just let me know just let me know when it's ready.
Okay. Yeah, we'll do. Thank you. I also wandered over back into OCAPN recently, was in a couple of the calls and reading through their specs and stuff. So yeah, it's nice to see that, a lot of capability stuff is moving forward here, which is always good.
By the way,
amazing.
At IIW, there was a great big regression back to authentication and away from capabilities. So the next IIW, I will once again be the anti-identity guy.
Yeah. I mean, that's even happening here when we're talking about local first stuff. There's a very clear distinction, right, between identity and auth, and people think of them as being the same. Like most users think of them being the same after 40 years of ACLs, right? I think we've got to a good place in one of the discussions, because again, people are doing things mainly with CRDTs in this community. And you have Z plus triangle, right? It can be an identifier can be human readable, decentralized, and secure. Pick two. And it's like, well, you want them to be decentralized and secure because it's all happening locally by default before you share, right? And then you need to map a human readable name to it. But the root of the authority has nothing to do with a person. It has to do with the resource. And they're also now starting to talk about things like, and maybe I'll even post the talk that I gave. They're like, how do I know? They're starting to move into compute. How do I know if my resource can be done locally, purely locally, is like pure computation, or with a resource that I have locally versus it's something remote? And like, capabilities will tell you that, right?
Yeah, no.
Do you have a capability to it? Is it remote or not, right? And you'll know. So I think there's some actually, Fission's been doing local first style stuff for almost 5 years. And I think the rest of the community is now far enough along that they're starting to think about these problems too. And I think there's actually a really nice use case for capabilities to handle a lot of those cases. So here's hoping, basically. Awesome. We're at the top of the hour. We're slightly over. Does anybody have other burning thoughts, questions, concerns, or should I let you all get back to your day? Anna? No. I thought you were putting your hand up for a question.
Sorry, that was mine. Bye, everyone.
Okay.
Sorry.
Amazing.
Late anyway.
Okay. Thanks, everyone. See you.